Good morning, Elizabeth. How are you?
Good morning, sir. I'm
You good?
okay.
Nice. All right. I'm just gonna wait another 10 minutes for others to just wake up and come in here.
Okay.
All right, cool.
So yeah.
Mr. Shan?
Good morning, Ali and Sasha. Sasha is long time. I don't see you. It's like about 2 weeks I don't see you, Sasha. Wow.
Excuse me, sir?
It's like about 2 weeks I don't see you. Are you okay?
No, sir.
You weren't
Not,
here last week?
sir, my internet is spotty.
Say it again?
I was here last week, but my internet is spotty.
Oh, okay. All right. I hope you access the recording and was able to go through the lesson. Were you able to?
And the document is sent in the group.
All right, good. All right.
But I still wasn't added to Edicosoft. You told me that you transferred me from the class I was in before.
Yes, you were.
Still not seeing it with my email.
I'm checking. And you are correct. Social. You are correct, social. Oh, yes, you were in that class. That class before, so drop you from there. These are them people who don't go them bed early on a Friday night, who wake up to Saturday morning. This means supposed to try enough for that class up to 9 o'clock last week. No, no, first of all, we need to check to see if you already dropped. So what I need to do is go back to here. To transfer from section. Instructor. Yes, Sasha, you're there now. You're supposed to be seeing it now. Sasha, you're here. All right, here. You log on this morning?
Yes, sir.
Yeah, so you're there now. All right, so
Thank you.
apologies for that. There's a student that I can't find Carry on daily. Carry on daily. I need to touch base with her. All right, let me see how many are here now. Just 5, just 4. Done is here now. All right. Yeah, it's a Saturday morning, so I'm not going to get agitated. I will talk about what was the last thing we did in class? Let me just project something here. What was the last thing we did?
Sir, good morning. I don't understand how I didn't get the link straight to my phone and I sort out everything with finance and all of that. Make sure but Excel say no. Excel says so slow.
Danny, good morning everyone.
Good morning.
Nobody got the link. They got the Excel spreadsheet. Because I was wondering as well when I looked in the email, I saw the Excel spreadsheet and not the direct link. So I'm not sure what is happening with Excel, sir. But I think there's a glitch with their system.
Maybe there's a glitch.
Because even with my grades, sir, there's a glitch with it, and that caused my GPA to drop.
All right, that I will have to investigate, but I know they sent out because I saw. Oh Lord, I don't even know. You know what I could do? Let me get the information directly from my ICT rep, and I can pass it on to you. I apologize on behalf of Excelsior for what has happened. And,
To be honest, I can't just wait morning to run off the 2 years and just change. Cause I'm tired of Excel, sir, honestly.
And I'm going to tell you something.
Welcome to the club.
No, but you see, I hold on because that's something interesting for me to talk about. So hold on a minute, please. I'm happy that you talk about that. Let me just
Sir,
something.
It's a very good topic because that's what exactly my group and I felt when we started Excelsior. And even going into our 3rd year, most of us was actually questioning if we should go.
All right, hold that point. That's not come. Hold that point. That's not back. Hold on 1 minute, please. All right. So allow me now to just address one or two of those issues. See, um, it is unfortunate that we have some year one students in the group, and I hear we have year two students and at least one year three student. But let me just explain something to you. And I have been teaching at Excess of almost 25 years now, and I have seen where Excess Community College has grown over the years. All right, has grown over the years. But I'm going to just tell you something, and I want you to hear me out. So I went to the University of the West Indies not once, not twice, but 3 times. All right. And I'm going to tell you, if I sit and I tell you the experiences I had, even at the point of me going into register, I had such a bad taste in my mouth. But at the time when I went to the university, way back when in the early 90s, we never had much places that offered degrees because the great UTech now was only cast. And the most they were offering was a diploma. And I couldn't come out of a degree program and jump into a diploma program with my parents. I'm sure I would not be alive now. So I had to stick with UA. I never had a choice. I had to stick with the university. And I'm telling you, ask most of your lecturers and they will tell you the same thing. They never have a choice. They have to stick with UA. No. Fast forward to 2021. We have so many competitors. Everybody just turn up and say, bam, university, we can offer you degrees. And some of them are not even accredited. The ones that Excess Community College are accredited. I'm going to tell you the truth. It may be that the individual, it may be that you are not finding the correct channel to get the information. You're going, what I find also is that some students, like I had a student who was supposed to graduate, but when she did her ratification, she found out that she's 1 course short, 2 courses short, 2 foundational courses, Foundation 1 and Foundation 2. I said, why didn't you read? Oh, because my friend who has a grade 1 in accounts told me that she never had to do it. I said, so what grade have in accounts? I have a grade 1 too, so I never bothered did anything. I said, okay, what did your friend also have? The friend did City and Guilds math and then only did foundation concept too. I said, did your friend tell you that she did all of that? No, sir. I said, that's a problem. I am saying this to say to you, class, sometimes we will link with our friends and our friends give us misinformation and we don't go and find the information out for ourselves. And then when we get into a bind, then this is what happens. Because the institution, when in truth and in fact, no complaint, no official information was passed on to your head of school, to your coordinator, to your head of department, right? We sit and rely on informal information. And that's one of the things that I find. Case in point, Elizabeth is a first-year student. And every day Elizabeth calls me. Mr. Shand, we know see the timetable. I said, Elizabeth, trust me, dearest, you will get it. And Elizabeth is here, so she can tell you whether or not I'm speaking the truth or speaking a lie. And I say, Elizabeth, trust me on this now, please. I am your head of school. And if I say to you that you're going to get it, you are going to get it. Just work with me. And she says, okay, sir. And then she'll send another message when she don't hear from me. Sir? And I said, okay. And the only reason I couldn't get it is because there were several things that we needed to have done in terms of finding the courses. All right. But the truth of the matter is, though, Elizabeth, as a first-year student, could have gone to some other first-year students and said, which course am I supposed to do? And go and select the incorrect courses. But she never did that. She came to her head of school or head of department and said, sir, what can I do? She had a problem finding, which one was it, Elizabeth?
Sir, I still don't find it.
No, man, you were finding precalculus. We're having a difficulty finding precalculus. I'm going to talk to you about the other course that we can't find because you're not the only one. Christian and DeAndre have the same issue, and I thought about why you're not doing it this morning, right? She was having a problem finding precalculus on the weekend. And every time she called me, I'm either in a meeting or in a class, but guess what? We eventually spoke. And I walked her where to go and get the information, and she found the information. So I'm saying to you, sometimes students, we get the wrong information, misinformation from our classmates because we don't want to take the time out to go and speak. You may say, but sir, when I call the head of school, I can't get the head of school.
That's a one-off situation, sir.
Hello?
Listen here, that's a one-off situation.
Sorry, speak up for me, please.
I'm saying to you, that's a one-off situation, sir.
Say it again.
That is a one-off situation. I've had
No.
issues with the department themselves speaking directly to the persons in charge, and I still don't get through.
And I mean, you see, and the thing about it, one of the things that one of the things that I don't appreciate, and work with me with this one, I can make a statement, and I'm going to ask you in the class to tell me if you agree or disagree. The Jamaican man, them worthless. They must take care of them me. Who agrees with that? You don't have to give me the reason for that, but just anybody just agree. Just tell me yes. If you don't agree, tell me no. Who agree? Who disagree? Just unmute and say agree or disagree. Hello, somebody. I'm going somewhere. Okay, so I guess we can end the conversation then because you don't want to speak. So we can move on into our lesson then. So what we did, so can somebody tell me what it is that we did last week? Remind me rather what it is that we did last week, seeing that you don't want to have a conversation. Is there anybody hearing me?
Yes, sir. Morning. I'm hearing you,
Morning.
but I was not present in the class last week. However, I'm trying to get the recording, and I will acquire that soon.
Okay.
I'm hearing you though.
You hear me? Okay. All right. Would you agree with me, Andrew? If I say that all Jamaican man them worthless?
Repeat that, sir.
Would you agree with me if I say the Jamaican man them worthless?
No, sir. Cannot agree on that. Not all.
All right. Why can't you agree with that? Because you're a Jamaican man and you know that you're not worthless?
That would be like your broadcasting everybody without doing a survey per se to find out if it is actually fact.
Okay. All right. Press pause.
Sir?
And that's exactly no. Hold on. I'm not taking any comment from you because I just asked a question and nobody was answering.
I'm not commenting on that in a second because I
No,
know
hold on, Ali. Because I was trying to get a conversation out of the class, and only Andrew alone answered, so I'm not giving anybody a chance just now. Out of principle.
Sorry, step away from my computer because I didn't.
Yeah. Okay. Fine. All right. So I'm saying is what I'm saying, Andrew, is I want you to stop there because one student may have a situation with one department at the college, and it so happens that it's their department at the college, and they broad brush excels at community college, and it's just one department them have a problem with,
Sir,
one
it's not
department
one department for me.
Ali,
One department for me.
hold on. Can you just hold on for me, please? So I'm saying to you, we have to be very careful because I'm sure many of you would have come across some lecturers who you may say, sir, I'm having a challenge getting this grade. They say, serious? I said, no, man, hold on. And they would have gone and intervened on your behalf in order to get the information. So we have to be very careful and just be very responsible when we say things that can prejudice somebody else's viewpoint on the institution. That's the point I'm trying to make. We have to be very careful. No, your situation may be isolated. Your situation may be isolated. When Allison's going to say to me that, and a number of our year 2, 3 students didn't want to come back and support, there are many reasons for that. There are many and varied reasons, because you know what? I would have taught quite a number of those students, and there are many of those students that would have said to me, and it's not because of necessarily the relationship that they garner from access to community college, but the reasons vary far and wide. So I'm just cautioning you. I don't know your individual situation, but I'm just cautioning you that when you're doing that broad brush comment, that you have to contextualize it. I can't say all Jamaican men are worthless. Yes, you may have that experience because your Jamaican father did not take care of you. You may have that experience because you see how your child's father take care of the child. But another person in your circle may say, well, my father wasn't there physically, but never tell you, not a school fee don't pay, not a lunch money no give, and him try. My father a farmer, but me not like you. Sometimes he not have it, but me not lie. Half dozen banana come and piece of yam come. So you have to be very careful in how we make comments and the impression that it leaves with others. That's all I'm saying. I'm not saying that your experience is not legitimate and you don't have a reason for feeling second wanted. But all I'm saying to you, be very objective with what it is that you're saying. Chances are, and I'm not saying that you don't have a point. You may have a point because of how you are feeling, but I'm just saying not everybody shares that commitment. And the final thing I'll say before I hear what Donnie and Ali has to say on the matter is try find one other institution and see if the situation is not even worse than what you claim to be. Some people go them and them church people them fall out and them say, oh, me I left a church here because one night hypocrite. I go one next church. And we don't go to church if I know say the same hypocrisy is there. You know what? The common denominator is people. People are the church. The church is not the building. Are people are the church. Who makes up excess of community college? You think it's at the building? 137 Mountain View Avenue? No. Are the people them there? So those are just a few words that I would want to share as cautionary advice that we are very mindful and responsible with when that we're saying something. All right. So I hear Ali that you are being very vocal. Go ahead, let me hear your other concern quickly before we move on. All right, Donnie, go ahead for me, please. Okay. So one of the things that I will apologize for is yeah, go ahead.
Sir?
Yeah, man, I'm
you
hearing
called
you.
me, right?
Yeah, man, I'm saying that you
Yeah,
can go ahead
you
and make a
called me
comment
just a while
now.
ago.
Go ahead and make a
Oh,
comment
sir,
now, honey.
never mind. Because I'm actually at Excelsior because I'm actually in a meeting with some other person. So that's why I'm at class at Excel right now. So I kind of
in a class now at Excelsior?
No, not in a class. I'm in a meeting
like
with
a group
some
meeting,
group members.
like a group meeting.
Yes.
Oh, okay, got you. No, but I'm just saying to you, do you have a comment to you were one of them who raised a point. You want to share what it is. You want to comment further based on what it is that I was saying.
No, sir, that's okay, sir. Because it's okay, sir.
No, but I mean, you see, that is so unfortunate. Again, it can't just make a broad brush comment like that and then just leave it hanging. So it is good for you to say something because I mean, chances are I can give you something. So it is good, since you made a comment in this medium, it is good to even share one experience. And okay, let me talk about the experience. You're talking about not able to get onto the, getting the link for the class. I can't comment on that because I don't know what is the reason. One of the things, this is done here, right?
Yes, sir, I'm talking.
One of the things that I can say to the class, Donnie, is that I know that you have been registered for this course because I checked that out. So I know that you have been registered for the course. So I can't speak definitively what has caused the issue with you not getting on. But I'm going to tell you something though. From about minutes to 8 o'clock, I have been trying to get onto the class. And from last night when I had my class 5:30, I can't get on Zoom with my tablet. I can only get onto Zoom with my cell phone and my computer. And even though I do all the stuff to get on, I just for the life of me, I just can't get on. And I'm saying to myself, why can't I get on? My tablet is such a useful device to use with Zoom, right? No, that is something that I will have to go and sort out. It's no fault of the college in that regard, but as it relates to not getting the link, yes. Clearly there is an issue by it is that you're not getting the link. And I can't speak to that. And I'm not going to justify that because I mean, if more than one student saying that they're not getting the link, clearly there has to be an issue surrounding that. And I will find out before class ends to give you a justification and in that regard. You know, Ali made a comment last week about how can somebody pass Precalculus and, I mean, not pass Precalculus, but pass the other courses. And I went and I did my investigation, and I'm okay with my investigation, because when a student makes a comment in my class, as one of the executive members of the institution and one of the persons, as I said before, that has been working there for many years, I have to come into the defense of my bread and butter, so to speak. No, if my bread and butter is wrong, ask anybody. I am the first to go into a meeting to say, no, you're wrong, and you could deal with it. I am the first, right? Because I always think like a student. So I'm saying to you, let us just wait and see how best we can circumvent the problem and deal with the issue as they arise. Okay. So with that said, again, I'm going to ask, what was the last thing we did in class again? I know we looked at some questions. I think, was it the 15 questions that we did? With the writing from the logarithms, to evaluate the logarithms. Hello, somebody, talk to me.
Yes, so we're looking at logarithms.
We're looking at logarithms. All right. Let me try and do something here. Let me do something here by sharing my screen. I need to share my screen and you tell me. Are you seeing my screen? These are the last questions we did, right? Somebody talk to me, please.
Yes, sir.
Yes, sir.
All right, good. So this is where we're going into. Yes, please. Go ahead, please. Who's this? Sound like Kerry. Hello? Kerry? All right. Yes, Kerry Berry.
Morning. Yes, sir, it's me. I just got.
Boy, you and your internet, I don't know why you don't get good internet service. So say all of us, because I'm there too.
Morning. Yes, sir,
Morning,
it's
Holy
me.
Bunches. Kerry Berry, I'm hearing you. Go ahead and let me know what is the problem. Hello, Kerry. All right. In the meantime, while Kerry sorts out our internet, Kerry, if you're hearing me, I'm going to ask that you log out and then log back in for me, please, Kerry. If you're hearing me, just log out, leave the class, and then come back in, please. All right. In the interim, what I want you to do for me, guys, is to look at the screen, work through the question that I have there, and then when I give you an opportunity to go through the question, then I will go through the question with you, because those are the types of questions that we want to do in class today. I'm actually on the final touches, so to speak, on this little area that we've been looking at. Tajay, are you in class today?
Yes, sir.
Didn't you see me put a message in the group for you yesterday?
Oh, no, sir.
Are you seeing the message in the group that I need to see you? I need to speak with you?
Oh, so yeah, I sent you a text, but
When you sent me the text this morning?
No, sir, about last 2 days, yeah.
All right, guys. Sometimes there are situations that come up and that I need to speak with you. And because of how you name yourself in the WhatsApp group, I don't know if this is Tajay or this is Georgiana or this is Kerry, or because you have different names on the stuff. So when I ask, I'm going to ask that you just keep in touch. I know Kerry, when she saw the message about preparing, Kerry called me and Kerry and I had a conversation. But I'm just going to ask the rest of you to just bear in mind that your teacher will need to speak with you. And when he sends a message in the WhatsApp group, not to ignore it, but to actually respond to me, because there was a message for you, Taji, that I wanted to um, just to touch base to get that. And I have to go think back now what that issue was. So please, it goes for everybody. If I send a message in the group and ask that you touch base with me, I'm going to ask that you just do that. If you can't speak at the time, send me a message, respond to the message and say, sir, I will touch base with you XYZ time, support and so on. But don't leave it hanging. And this again accounts for some of the problems, because it's an issue that I saw that I wanted to resolve. And I don't want anybody to say that, an issue is present and it was not resolved. But anyhow, look at the question on the screen for me now, please. And when you have done that, I'm going to ask you to. I'm going to give you about 5 minutes, and then I will come back to you with the explanation as to what is happening. So start working for me, please. All right, I think I would have given you enough time to look through and to generate your own questions. So when I'm going through now, you can ask me those questions. And I want you to work with me now. All right, so the question says to evaluate 5 raised to the x power equals 10. 5 to the x power equals 10. Now, one of the things I'm going to ask you, let's just see if we can do a guess. We're playing a guessing game. The guessing game is, let us guesstimate that x is 0. Let me bigify this somewhat. Let me guess that x is 0. We know that anything raised to the power 0 is 1. If it's not 1, 1, 1, 10. So x can't be 0, but we could try 1 now. But 5 to the first power is 5. Still not enough for 1, 10. Let us try 2. 5 squares is 25. We'll pass it. We'll pass it, because 10 lies between 5 and 25. So it implies that our answer is between 1 and 2. So why 1 and 2? See here, x is the unknown, and if the unknown is at 1, the answer is 5, and the unknown at 2, the answer is 25. That means our answer lies between 1 and 2. So this is one good way of us getting an answer like this to guesstimate what our result is going to be like. So if this were a multiple choice test, and you see all the answers there, but it's just one answer that lies between 1 and 2. Say, for example, 1.456. And that is the only answer that lies between 1 and 2. You don't have to work out nothing. 1.456 is the answer, right? Because you know that is it. So I'm teaching you also how to answer your multiple choice questions. All right? I'm teaching you also how to answer your multiple choice questions and answer them quickly too. So it says to determine the actual value, we do the following. We need to take the logarithm of both sides. But before I do that, I want to talk to you about something. Do you recognize that I cannot write the right-hand side in a base 5? Tell me if you can write the right-hand side in a base 5. Hello, guys. I did ask a question. Are you guys hearing me?
Yes, sir.
All right, hold on. Let me just take a break. I need to. Sorry, I soon come. This is foolishness. It's not. It's really Hello, students.
Yes, sir.
Yes, sir.
All right. I just need to ask a question because at this point in time, I'm a little agitated, and I know I'm being recorded, and I'm going to do this in the right way. Do you want to have class this morning? If not, I will give you the time off. Last week, I had a long conversation with you about me asking you questions, and you guys are sitting there, and I have to wait before somebody say, yes, sir, we are hearing you. And I'm not going to go through it again. So if you don't want to have class, just let me know. Or if you want somebody else, I can reassign the class to somebody else. But the vexation of the spirit is working this morning, and it does not make any sense. I had to go and take a long walk a while ago. I am going through something that we're doing for the first time. I have typed one line, number one, and I'm asking a question and nobody's answering me. I'm not going through it today. I'm serious. I'm not going through it. So if you are otherwise engaged and have other things to do, I will give you the time off. And I'm serious about it. I'll give you the time off so it is that you can go and sort out the stuff. And then if you want us to rejoin sometime later, I will, once it is that it's within the class time, I will rejoin. But I'm not going to be sitting here and talking to myself. I could do this whilst in my bed lying down on a Saturday morning. It's not going to happen. Not today, not no other day. So please, let me know now whether or not you want to have class so we can continue with class.
Sir, morning again. I am here now, ready and I am ready now, sir. Honestly, I was at work and just came off and signed in. I'm about to sign in the computer, but I'm basically ready now.
Okay, Andrew.
Sir, where my internet is unstable. So when I was trying to answer, it says internet unstable, and it's saying it again.
Okay,
so,
Kerry.
I wouldn't hear you saying something and don't reply. So I apologize for that. But we want class today.
Okay, thanks, Kerry.
Yes, sir.
There are others
So
here.
you can go ahead with the class, sir.
Okay. I need to hear from everybody, because this is really I think I'm internalizing it. I could be engaged otherwise. That's the point I'm making. No, I can understand. I know Kerry has internet challenges. I know Andrew's situation because he has previously explained it to me, right? But what about I know Sasha's situation, right? Kerry, can you call Lori for me, please? She has been missing too many classes.
Sure, sir, I will.
And I don't know. All right. This class is not like the other classes that you may have, where we sit on in class and teacher calling upon you and then I don't want to answer. My class is supposed to be interactive. My class is supposed to be interactive. All right. So I'm going to ask you one more time. When I ask you the question, I'm going to talk to me. That's all I'm asking. If you don't know it, it's not a problem. It's not a test. Jesus, Lord, intervene. All right. So I was saying that we need to check to see if the right hand. So we need to determine determine the actual value. To determine the actual value, we need to do the following. All right. So we need to check to see if the right-hand side of the equation can be written in the same base as the left-hand side of the equation. We need to see if the right-hand side of the equation can be written in the same base. Now, my question to you, am I able to write this 10 into a base similar to this one over here?
Yes, sir. Should be, because
tell me what I could write then. If you say yes, what I could write. 5 to the first, 5 to the second, 5 to the third.
This, I think, is the second. Oh.
5 to the second is, look at this, Andrew. 5 to the second is 25.
Oh.
This is not 25. So here my
It's
question
first
to you
then,
again.
sir. 5. Oh.
5 to the first is 5. Is this 5?
Oh.
So am I
No,
able
sir.
to write it in the same base?
I guess not.
Right. So I'm not able to write it in the same base. So that's one of the things. So once I can't write it in the same base, we need to take the logarithm of both sides. And that's how you know whether or not you can use indices versus logarithm. So if you can't write it together as the same base, then we have to go and take the logarithm of both sides. We have to take the logarithm of both sides. If we can't write it in the same base, we have to take the logarithm of both sides, right? Now, to take the logarithm of both sides, we are going to recall log to the base a of b to the n is equal to n log to the base a of b. Log to the base a of b to the n is equal to n log to the base a of b. All right, now, what I'm doing, go ahead, go ahead. Sorry, somebody saying something? Is somebody saying something? All right, so what we looked at,
sir.
okay, so what we looked at last class was the log to the base a of b to the n is equal to n log to the base a of b. All right, so that's one of the laws of logarithms that we have to get with. Log to the base a of b to the n is equal to n log to the base a of b. We can't forget that law because that's the law where we
Sir, I'm not hearing you. I'm not sure if you're talking.
Hello.
I think sir might mute now. Not sure if you know that.
no, my mic not muted.
Oh, it was
Okay.
before.
It was before. So you hear me now?
Yes, sir.
All right. So I was saying, sorry about that. These things happen. So I'm saying to you, where was I? I was saying to you that log to the base a of b to the n is equal to n log to the base a of b. Something that you can't not remember. You have to remember this. Log to the base a of b to the n is equal to n log to the base a of b. Very important. All right. So when you look at 5 raised to the x, we are going to be saying x log 5. Look back at the law that says log to the base a of b to the n is equal to n log to the base a of b. Log to the base a of b to the n is equal to n log to the base a of b. All right. So when we say log 5x, 5 to the x, 5 to the x is equal to 10. We are going to be writing that in the form log to the base a of b to the n is equal to n log to the base a of b. So we're going to have 5x log 5. Can you see that conversion from the law that I gave you? Look at the law in orange. Can you see that conversion? In order for me to get x log 5 equals log 10. Talk to me. X log 5 equals log 10. Can you see that? Right. Is there anybody in the class that is not seeing that? Talk to me so I can go it over. All right. So
repeat that, sir. You said, just a second, sir. Repeat what you said earlier.
no, I'm saying log to the base a of b to the n is equal to n log to the base a of b. Log to the base a of b to the n is equal to n log to the base a of b. So I'm saying
that
to you,
example that is showing right there. Okay.
right,
I'm with you.
right, good. So I was saying to you, are you seeing then how I was able to move from 5 to the x equals 10 to x log 5 equals log 10. Look at it and tell me if you say, oh, I was able to move from that using the law.
Sorry about that. You can go over that, please.
Log to the base a of b to the n, log to the base a of b to the n is equal to n log to the base a of b. Log to the base a of b to the n is equal to n log to the base a of b. See, I'm saying to you, if you are given 5 raised to the x power, 5 raised to the x power is equals to 10. I am saying x log 5 is equals to log 10. Hello, somebody?
Yes,
X
sir,
log.
I see it, sir.
You see it now? All right. So what you need to do for me now, I want everybody to grab your calculators. Everybody to grab your calculators. Very important. Very, very, very important step. Everybody to grab your calculators for me. And when you grab your calculators, I want you to evaluate log 5 and see if it's the same answer that I have there. And I want you to grab your calculator and evaluate log 10 and see if it's the same answer that I have there. If not, we need to talk about it so it is that we can have our calculator issue sorted out. Log 5. My answers are there. Look at it, log 5. Then we evaluate log 10 and tell me if it's the same answer that I have. It's the same answer that you got. If not, we need to talk about it. Hello, somebody?
Yes, sir, I checked it. It's correct.
It's correct. All right, that's one person. What about the others? No, I know mine is correct. You know, I just wanted to find out if you can get yours, if you know how to use a calculator to get your answer. So I need to hear from the others. If you see how we got that piece there.
So you said the log piece you're talking about is the 5 raised to the 1 and the 5 raised to the 2?
No, man.
So which log piece you're talking about, sir? Because when I do log 5, I get 0.6. I log 10, I get 1.
Did anybody else get the answer that I have on screen? Do you all have calculators with you?
Morning, sir.
Good
Sorry for
morning.
being so late.
Yeah, man, no problem. Do you all have calculators with you?
I don't have one on me because I'm on the road, but I'm following.
Okay. For those of you who have calculators, can you speak to me, please? I need to know if you are getting what it is that I have on screen.
No, sir, not from me. I'm not getting it.
You're not getting it? All right. Look at the calculator.
Sir, me get.
I'm hearing you, Elizabeth. What you getting?
Sir, I don't get the 1.43. I got 1.55.
1.55. And tell me how it is that you're putting it in on the calculator.
Log 10 divided by log 5.
No. Hold on. What I'm asking you to do, what I'm asking the class to do, is to evaluate log 5 and see if it's the same answer that I have on screen that you are getting.
Sir, log 10 is 1 and log 5 is 6.
Log 10 is 1?
Yes, sir.
Everybody got log 10 to be 1?
Yes, sir.
Yes, sir. I can't
Tajay, what you got for log 10?
Tara just
One, sir.
disgusting. I can't stand Tara. Jesus.
And what do you get for log 5?
Zero point 698.
0.698970043.
All right, great. When you do the conversion, you're saying that you're not getting the same answer I have there? Because Tajay said that he was getting
No, sir.
Tajay said that he was getting the same answer. Is it that you're changing the mind now, Taj?
Oh yes, sir. Something wrong with my computer.
Something that I have there is incorrect. That's what you're saying, Taj?
Yes, sir. Because when I log 5 equal log 10, the answer.
All right, say it again, Papa. I'm not hearing you. Say it again.
I was saying when I'm using log 5 equal log 10, it's not giving me the answer.
It's not even an answer. All right, let me grab my calculator. You see, sometimes I do this thing. The preparation of the notes, almost in a rush. And sometimes what will happen to you will happen to me in terms of the calculation.
Deka. Which did you get what Deka?
Calculator. Log 10.
Everett Orlando Walker. What they doing?
Alison, you might want to be muted.
So him can't talk no loud, and when me ask a question, she can't answer me. Like funny.
Sir, my answer you.
I don't want to hear nothing from you. So you talk about a boy Orlando Walker, but when me ask a question, you don't hear me because you're having conversation out the door. It's all right, Alibali. There's no love lost, but it's all right. I thank God that your mic was open just now, so I could
Sir,
hear
I
you.
answered you earlier, no, sir.
Okay, whatever, Alibali. Did anybody get the 1.43?
Sir,
Yes, please.
sir, remember that I was at school, so actually I have to go up and down. So I'm actually going home back now.
Mm-hmm.
So I
You're not
will
being able to
join
participate.
back.
All right, no
Repeat,
problem.
sir?
You're not going to be able to participate. No.
Yeah, I'm going to leave right now and go home. It never take long. So reach
All right,
home.
then. All right, cool. Be safe. Put up your cell phone.
Yes, sir. Yes,
All right,
sir.
cool. All right.
Yes,
So
sir, I got the 1.43, sir.
Okay, great. All right. So sorry, Elizabeth. I'm trying to remember your name, Beth. Elizabeth, look at it now and tell me if you get the 1.43, honey. And Andrew, look and see if when you divide log 10 by log 5, you get 1.43.
Okay, sir.
And Kerry, if you're hearing me, I want you to do the same thing. Sachel, please do the same thing. Georgie Podgy, I need to hear from you also. Tajay, Tasika, come on, we need to hear you guys. 11, 12.
Yes, sir. 1.43.
1.43. All right. Now, let us go back to the question. So we're saying that x is approximately equals to 1.43, because when I say approximately equals to, it's because you have 1.43 enough more decimal places come after the 3. All right.
It's not exact.
Right. It's not an exact answer. So look up. Let us go back to the question up top. No, we guesstimated that our answer lies between 1 and 2. No, 1.43 lies between 1 and 2. So do me a favor now. I want you to put 5 raised to 1.43 and see what you get for your answer. 5 raised to 1.43 and see what you get for your answer.
So I got 9.989. So it would be for 10.
Very good. All right. Proof. So you're gonna have 5.
Yeah, 9.98.
9.98.
9.99.
9.98.
Yeah.
That's what you got to write, Taj?
Yes, sir.
Nice. So if you do that, you see that it is approximately equals to 10. Let me just find the approximately equals to sign. Approximately equals to 10. All right. So that's one way. Why I'm doing this proof? That's one way for you to double check your answer. So when you get your stuff, you can go ahead and double check your answer to see that you are actually on the right track. All right. So let me ask you, is there any question relating to what it is that I just did with you? Do you think it's an easy way to go through the stuff? I said something that is very important right here, that to check to see if the right-hand side of the equation can be written in the same base as for the left-hand side, right? If it cannot be written, if your answer to that is no, if it cannot be written, then we have to use logarithms. Then we have to use logarithms. And to use logarithms, we're going to be applying this law. Log to the base a of b to the n is equal to n log to the base a of b. So I'm going to go and say x log 5 is equal to log 10. So I'm taking the logarithms of both sides, right? So we need to take the logarithm of both sides. And in so doing, I'm going to go through and get this line. Then in order to find the value of x, I'm going to isolate it by dividing both sides by log 5. Not log to the base 5, no, just log 5, because when you're not seeing a base, you assume 10. So I'm going to divide both sides by log 5. So I'm going to have log 10 divided by log 5, and that is going to be equivalent to 1.43. All right? Now, I want you to do me a favor. Question 1 through 5 is what I'm going to give you for classwork. Question 1 through 5 is what I'm going to be giving you for classwork. Question 1 through 5 is what I'll be giving you for classwork. Question 1 through 5. I'm going to ask that you zoom in for me. Oh Lord, I'm trying to get all of this on one page, guys, so that you can see the classwork. Let me close here. That you can see the classwork as well as the example together. Hold on, just work with me 1 minute, please. All right, I just need to do this one more time, and I should be able to. All right, I should have it now. No, I don't. All right, go ahead. You can follow the question from there. This is the first part of it's just the original question that is missing. 5 to the x equals 10. It's just a question that is missing. Go ahead, Andrew.
Yeah, so we're supposed to do 1 through to 5, right?
1 through 5, no, right. And look at it. My answers are here. These are the answers I got when I did them for you. So you are going to work them. If you don't get the answer, it's not a problem. Once you reach the answer, you don't get that answer, stop. Move on to the other question. If you don't get the answer, when it stop, because I will go through the question with you. All right, but I want you to work 1 through 5 for me now. Thank you. And I'm giving you 10 minutes to do that. 2 minutes per question. How is it going?
Okay, sir.
Nice.
Sir, I'm finished.
Oh, that's very good. How far you reached, Dad?
Oh, sir, I'm almost finished. I'm at question 4.
Good job. All right. Andrew, how far you reach? Okay. I'm just seeing this message. Good morning, Lorian.
Morning again, sir.
Okay. How far are you?
I'm at number 3.
Okay. All right. Hurry up for me, please. Georgia Podgy. Sachelle, how far are you? Jessica, how
Yes,
far are
sir.
you? How far are you?
I'm finished. I told them.
Oh,
3.
sorry. You did say that you're finished. Sorry. Jessica, how far are you? You said 3?
Sir, may I try a thing?
Mm-hmm. That's the aim. Davy, how far are you, dearest?
I'm at number 3, sir.
Good job. All right. I'll give you a few more minutes. I really want you to do this on your own, and then I'll come in and do my little own little thing. All right. I'll soon come back. I'm right here. Are we all finished now?
Yes, sir. I'm finished.
All right, good. Anybody else still working? All right, so let me walk you through. I don't have the solution typed out. Let me walk you through the first one. And if you need time to go and fix the others, no problem. 3 raised to the x power is equal to 6. My first question to you is, am I allowed to write the right-hand side of the equation as the same base as the left-hand side of the equation?
No, sir.
No, sir.
And as a result, because you answered no and answered it so boldly, it means therefore that I must use which method?
Logarithm.
Logarithms. And if you speak to me like this in class, there is no way you can fail the course. Logarithms. So you're going to ask yourself the question and you hear no, logarithms. All right? If you, hear me out. If you said yes, what could you have used? Tum 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 tum. What else? If you had answered yes, what else could you have used in this case, in that regard?
Between 1 and 2.
No. All right. So what if if I'd given you the question, say 2 raised to the x power equals 4. 2 raised to the x power equals 4.
So convert to the same base.
They can convert to the same base?
Yeah, the 2 to the x power equals 4.
Okay, so since I can convert to the same base, what do I do? What could I do then? Convert it. Okay, do the question for me. 2x equals 4. 2 to the x equals 4. 2 raised to the x power equals 4. I want you to do that question for me because I'm bringing out a very important point and I want you to see. 2 to the x equals 4. Bring that out and convert the right hand side.
Sir.
Yeah.
Sir, can you go a little slower, please? And get what you said about the solution that you can't type it out? Because I would like to see it.
All right. Can you work with me, please? Because I've moved on to something else and I'm not going back to that just yet. I've asked you to write for me 2 raised to the x power is equal to 4. Work with me, no man. Jeez, 2 to the x equals 4. Have you written the right hand side of the equation to convert the right hand side of the equation for me already, class? And if yes, tell me what to convert.
So that be 2 to the second power.
Very good. 2 to the second power. Right.
And
now continue.
Equal to.
How you know that? No, man, we're getting somewhere, man. Tell me how you know that. We're getting somewhere. Tell me how you know that.
Sorry, because I did it already.
Yeah, man, but talk to me now, man. I want to just bring across a point. So tell me how you know that. What statement we make? How we know that? What do we say?
Because since the bases are the same,
Very good.
You just something the power.
What kind of something that is? Tell me what something that is.
So the power, the x to the x. So we don't know if
very good.
that far.
So we equate the powers.
Yeah.
We equate the powers. All right, very good. Now, excellent. So that's why I want you to work with me now. Good. So what I'm saying to you is, so since the bases are equal, we are going to be equating our powers. Very good. Very good. All right. So now we will say that the value of x there is going to be 2. The value of x is going to be 2. Sir, how did you get 2 again, sir? We got 2 because since the bases are the same, we equate the powers. Since the bases are the same, we equate the powers. All right? Okay, so continue working with me now. Let us go back to the question now. 3 to the x is equals to 6. 3 to the x is equals to 6. And here my question to you. Am I allowed to write the right-hand side in the same base as the left-hand side?
The same question, sir. 2 to the x equal 4?
No, man, the one with the 3 to the x equals 6.
Oh.
Alison, at this point in time, you are supposed to be coming in now.
I'm going to say yes, sir.
Sir,
Sir, no, sir.
You can't. Remember we just said we can't, Andrew? We
Oh,
can't.
no, I just came back, sir.
Oh yeah, you did say that you wanted 3 minutes. Right. So you can't. All right. No, Elizabeth. So I hear you say no, and I hear you loudly. All right, Elizabeth. So this is a question for you, Beth. If I can't write the right-hand side in the same base as the left-hand side, which method do I use, Beth?
Sir, n log AB.
Good. So I use logarithms.
Log AB n equal.
Fair enough. Fair enough, Beth. So very good, Beth. Answer this other question, no, Beth. So if I can write the right-hand side in the same base as the left-hand side, what method can I also use, Beth? What method was the one that we used a while ago for the 2 to the x equals 4?
Indices.
Indices. Very good. Excellent. So what happens is when I can write the right-hand side in the same base as the left-hand side, I can use indices. When I cannot write the right-hand side in the same base as the left-hand side, I must use logarithms. All right, fine. One other question for you now before I move back to the question, because this is to get you to understand what is happening. Write for me, please. Write for me, please. 2 raised to the x power equals 4. The same question. 2 raised to the x power equals 4. 2 raised to the x power equals 4. And I want you to use that question as you are using for logarithms. Say it in a recognize. Say it in a recognize that it can be written in the same base. So I want you to use it as logarithms for me. I want you to use it as logarithms for me. And tell me what you get for your answer when you do the logarithms method. What's the answer?
Sir, 2.
2. You use logarithms and get the same 2?
Yes, sir.
Yes,
All
sir.
right. Okay. What conclusion can you all draw for me, having used logarithms, and we still get the same 2? I want somebody to draw a conclusion. There is a conclusion that can be drawn. What's the conclusion?
Sir, you can use any method to get the answer.
Okay. Very good. Any method to get the answer when? Any method to get the answer when? Any method to get the answer when?
When the bases are the same.
When I can write both left-hand side and right-hand side in the same base. Look at it and tell me if you agree with that statement. I can use any method when both the left-hand side and the right-hand side can be written in the same base. True or false?
True.
All right, good. Andrew, you see what I'm talking about there?
Yes, sir.
Good. But when I can only write the left-hand side, when I only can write one side, and incidentally, it may not only necessarily be the left-hand side, it could be the right-hand side alone. When I can only write one side of the equation in a base, it means that I can only use logarithms. I can't use both, right? When I can write both sides in the same base, I can use any of the 2 methods, indices or logarithms. indices or logarithms, right? So it's very important for you to recognize when I can write both sides in the same base, I can either use indices or logarithms to evaluate my answer. But when I can only write one side of the equation in that base, it means that I must use indices. It means that I must use indices. All right? Okay. So I really hope that point is taken care of. I hope you're seeing that point. And if you're seeing that point, then we can move into the other areas. All right? So let us go back now to, matter of fact, are there any questions regarding that, what I just explained?
Yes, sir. Can you repeat that?
All right. Who is that? Who was that? Alison?
Danny.
Donnie. Okay. Oh, I was about to ask, Donnie, if you're back yet, All right. So what I'm saying to you, let me see if I can make a notation here so that I all right, so let me put a summary. When both sides of the equation can be written, written in the same base, comma, then we can use either indices, IN, or logarithms to solve the equation. If, on the other hand, only one side is written to a base, if on the other side only one side is written all right? So when both sides of the equation can be written in the same base, then we can use either indices or logarithms to solve the equation. If on the other hand, only one side can be written written to a base, then you must use logarithms to evaluate the question, right? So if one side is written to a base, then you must use logarithms to evaluate the question. Very, 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 very important. Extremely important that you remember that. All right. All right. So you see what is happening now? I still can't get to do the question yet, because there are so many things that are coming out that we need to talk about. So let us see if we can finish answering this question now. So in finishing this question, where are we? In finishing this question, three to the x is equal to 6. Did everybody get as their answer 1.63?
Yes, sir.
Yes, sir.
Who did not get the 1.63 for the answer? Let me hear, please.
Sorry, the internet kicked me out. Could you work that one so I could understand, please?
I have no problem, Kerry. I have no problem, Kerry. No, that's fine. That's fine. The reason I ask a question like this, and I'm going to say, the reason I ask a question like this, because I don't want you to think that all the questions that I will ever find and give you in a class to do, I am going to come and sit and work all the questions. I don't have a problem, Kerry. I can work this, but I will not work all the questions that I give you. All right? What I try to do is to give you the answers for all the questions that I give you so that you know whether or not you're right or wrong. Like I have here, I think, all the questions, yeah. But I can work this one, not a problem. Not a problem. Copy. And let me put the solution under here. SOLUTION is his. All right. Now let me just, for ease of calculation, let me just do this quickly. All right, so what I'm going to do here now is to say x log 3 is equal to log 6. X log 3 is equal to log 6. X log 3 is equal to log 6. Then we're going to be dividing both sides by log 3. We're dividing both sides by log 3. Why, sir? So that I can determine my unknown x. So I'm going to have log 3 divided by log 3 over log 6 divided by log 3. All right? And then when I have that, I'm going to cancel out my log 3s. I'm canceling out my log 3s. And then I am going to have, that's log 6. Then I'm going to have log 6 divided by log 3. No, put on your calculator, Kerry. Log 6 divided by log 3, and tell me what you get for your answer.
I remember I do have a calculator with me.
Oh, yes, you did say that. You did say that. You did say that. All right. So when you do that, Kerry Berry, you need to get one here. Come next class, you need to have one.
Yes, sir, I have it, but I don't have it on me because I'm on the road.
Fair enough. Got your honey bunches, loud and clear. Clear as mud. Let's go. So when I have my x is equal to log 6 divided by log 3, when I divide both sides by log 3, I'm going to get log 6 divided by log 3. And when I do that evaluation, I am going to get 1.63 to 3 significant figures. No. When I talk about 3 significant figures, you know, the man then can say to me, put it to 2 decimal places. All right. And whatever else the situation is. So just look to see how they ask you to leave your answer, and then just leave the answer in that appropriate place. Right? So just look to see how they ask you to leave the answer and leave the answer in that place. All right. Okay, now. Number 2. Are there any questions, re-1? Are there any questions, re-1?
No, I'm not getting that one.
Sorry, you're not getting what?
I'm not getting that one. I put it in my calculator.
Oh, you're not getting, okay, put, all right. Oh, Lord.
Sir,
yes, please.
Is it the, what you call the A, B over C? Because when I use the A, the button that says A, B over C, I get a different answer. But when I use the division sign, I get the 1.63.
Yeah, because the A, B over C is when you talk about a, well, then again, no. Nobody should get it with that, you know.
No, sir, no, I don't get it to that.
All right. Do me a favor. Press log 5. No, sorry, log 6. Press log 6 for me.
Yes, sir.
And then press the ABC button.
Yes.
And then press your open parenthesis. Open your parenthesis.
Okay.
And when you open your parenthesis, you're going to press log 3.
Still on then,
then you close the parenthesis. Hello, you're not done yet. Close the parenthesis and then press equal.
Yes, I would have still like it. Let me get 1.099.
Sure, wait them. No, ABC button for my own.
Look to the left.
Look to the left.
About the 3rd row under the left.
Yes. So I'm going to use a different calculator. So hold on.
A and B over C. That
right.
one?
Yeah, man, that one there.
Log 6 and press it, and what else?
Log 6 Then you open your parent. No, sorry. You press log 6, then you press the ABC button. And then you go ahead and press log 3 for me and tell me what you get.
So I use a different calculator and still get log 1.099.
All right. Danny, what you get?
I'm trying, sir.
Okay, I'll just wait until you finish and then I will talk again about that. I don't know why you're not getting the answer.
Log 3. I get 0.45, sir.
No. All right. I'll soon respond to you about that one then.
Alright.
Try for me. Both of you. Try for me again. Try for me. Log 6, and then press the division button, not the ABC, you know, the division button. Press the division button, and then press log 3 and tell me if you get the answer.
Yes, sir. When I do that, I get the 1.63.
You get the 1.63 when you do that?
Yes,
I
sir.
got 1.099.
When you do it that way?
Yeah.
Rock stone.
I don't know if my calculator is in a different mode or because it's always changing notes. Let me try again.
Look above it if you see a D or you see D on the screen.
What must be on it?
D or DEG.
It's in D.
Yeah, but I mean that won't affect you when you're doing trigonometry still. That won't affect when you're doing trigonometry. All right. Let us move on for now. Let us move on for now, and then sort. Let us move on for now and then sort out that piece. That piece is my homework. I need to know why you're not getting the answer when you use that. When you use that methodology. Let us move on to the other question. What was the other question, please? By the way, before that, Kerry, you see how I get the answer with the 3 to the x equals 6 now?
What, sir?
You see how I got the answer with 3 to the x equals 6?
Yes, sir. I followed how you got this to the stage.
All right, good. What is the other question? Remember the other question, please. Question, please.
That is 5x
Equals 4.
No, man, it's not 5x. Andrew, read it properly, Andrew, please.
5 to the power of.
Very good.
5 raised to the
power
power of x equals 4.
All right, so here's my question to you. Am I able to write the right-hand side of the equation in the same base as the left-hand side? Answer, please.
No, sir.
So therefore, I must use which method?
The indices.
No, logarithms.
Oh, hold on. You see when you can raise both sides.
Right. Both sides
So
I use which method?
The same way you use the logarithm or the indices.
No. Right. When I can raise both sides to it, I can use either of the two. Indices or logarithms.
Yeah.
But when I can only write the right-hand side or one of the sides in a base, I can't use indices. I can't use indices. I have to use logarithms.
Okay. Well, I made a mistake there.
Good, great. So only when I can write just one side of the equation, I can write as a base and power. Then I use logarithms. Only when I can write one side, I use logarithms. But when I can write two sides in the same base, I can still use the logarithms, but if I want, I can go ahead and use indices. You follow me now?
Yes, sir.
All right, cool. All right, do that question for me, please, and tell me what you got for the answer.
Did it already. I got the 0.86.
0.86. Are you all?
0.86, yeah.
Are you all agreeing with that answer, class? Alison?
Yes, sir.
Alison?
Yes, sir.
You see, you are the same one who can come out and talk about, sir, do it on the screen and I can't understand and you're not participating or not all in Alibali.
Sir, but so now me and you go through the question a while ago, sir.
Ali.
We give up. Sir, we give
don't,
up.
don't let the station of the spirit take place this Saturday morning here. Leave Orlando alone.
Sir, we give up. That's my child, says my child. It's my turn,
Sure. All right. Whatever. Come, let's go. That's what you call him, no, your child. All right, let's go, guys. All right, let's go, guys. All right. So what I want you to do for me now, I want you to double check that answer to see if you get what it is that is correct. So you said that your answer was point what, Andrew? Point how much? 0.8?
Yeah, 0.86, sir.
0.86. What I want you to do for me is to press 5 raised to the 0.6 and see if you get 4 for your answer.
I got this 2 points. There's a 5. Hold on, this over.
So what you saying for the now, sir?
Substitute that answer into it. And see if you get the same thing. Substitute that answer into it and see if you get the same thing for it.
3 raised to the 1.6.
So 5 raised to the power of what, sir?
5 raised to your answer.
5?
Oh.
Sir, I'm
5 or
at
3, sir?
3.9.
Yeah, man. 3.9 is fine. You know why it's 3.9? Because it's an approximated answer. You get to know.
Yes, sir. 3.99.
Yeah, man. It's not an exact answer, so it's going to be approximated. Let me just talk about that. Look at why it is 3.9. It is 3.9 because this is what I put here. Approximately equals to. This sign means approximately equals to 1.43. Why is it approximately equals to 1.43? It is approximately equals to because it is 1.43 and you have additional numbers there. So it's not a terminating decimal. All right. So this one, you'll get an exact answer. So when you put the answer into this, you get this exact. This will be an exact answer. Follow me? Somebody talk to me now, please.
Yes, sir.
All right.
Yes, sir.
All right. Do me a favor now. Thank you. Do me a favor now. So I'm dividing both sides by log 2 here. Log 2 divided by log 2. I'm only doing this so that I can send you the notes when I'm finished exactly. And log 2 divided by log 2. And this is going to be log 4, log 2, and log 4 divided by log 2. Log 4 divided by log 2 is going to be equals to 2. So I need to show you something. All right, so look. So look at the difference with this answer here. You notice when we did the first one, I get my answer to be exactly 2, and I don't use the approximately equal sign anymore. I use equals to 2 because this is my precise answer. I never needed to round off. The other questions, I had to round off. This one here, I didn't. All right? That one here, I didn't. Let me just do this one here for your sake. What was I looking at again? Equation. Since the bases are the same. Oh, come on. Copy. Example 2. And I'm going to paste this one here, and then I'm going to call this example 3. Copy. I'm going to call this here. Paste as example 3. And just put down the thing. Then I'm going to copy that. And then I'm going to put 2 squares. And then I'm going to say,
My name Kerry. My WhatsApp phone
no.
work. It's
Kerry, mute.
Sorry, sir.
Yeah. All right, so this one here, this one is finished quickly. So you recognize here, so that the question finished so much quicker when I can do indices as opposed to the logarithms, but we have to learn the logarithms. So we get our answer to be equal to 2 in both cases, right? But I'm just showing you my summary. My summary comes after this now. My summary is now saying all of that. And then I'm giving you the exercises, all right? So I feel comfortable with what I have done there. So 0.861, all right. Number 3, where was number 3? Number 3 is 2 to the 2x power. Everybody got that one okay? Copy. Number
Yes, sir.
3, all
Yes,
right,
sir.
cool. All right, I'm just gonna do that one and then and then I'm going to jump to this here is going to be 2x log 2 is equals to log 5. And then I'm going to divide both sides by log 2. And then to get the unknown x, and then log 2 divided by log 2 over log 5 divided by log 2. And then when I divide both sides, by log 2, I'm going to have my 2x is equals to all of that, which is log 5 divided by log 2. And log 5 divided by log 2. Log 5 divided by log 2. Do that for me, please, quickly. Log 5 divided by log 2. And to what you get?
2.321.
2.321. 2.321. And then when I divide that by 2, I'm going to get 1.63. All agree?
I got 1.16.
Yeah, that's what I said, 1.16. Oh, you got 1.16?
Sir.
Let me check my answer. 1.16 for number 3. You're correct. 1.16. I had copied that from something else. It's approximately equals to 1.16. Oh Lord, I changed the wrong answer. Undo. Change the wrong answer. 1.16. That's where I copied it from. 1.16. And then that one's supposed to be 1.63. 1.63. Yeah. All right. Now, let me jump to question 5. So I'll just do the odd number ones. Question 5. Question 5. Copy. They're all the same. Pretty much. It's just that you may get a whole number, or you may just get x alone in the numerator, or you can get x and like 2x, a multiple of x, or you can get a linear function like this one, 2x plus 1. They can give it that. Or they can give you something that is quadratic, and then you go ahead and solve the quadratic one, right? Really not anything different. So we have 2x plus 1 here, and we have 2x plus 1 log 4 is equal to log 3. And then I'm going to divide both sides by log 4. I'm dividing both sides by log 4. then what I'm going to have is 2x plus 1 log 4 divided by log 4, because I'm dividing both sides by log 4, is going to be equal to log 3 divided by log 4. And that's what I will get. And then when all right, log 3 divided by log 4 2x plus 1 log 3 log 4 divided by log 4 I'm going to end up with 2x plus 1 is equal to log 3 over log 4. And what is log 3 divided by log 4 equals to? What is log 3 divided by log 4?
0.79.
2, yeah.
0.7912?
No, 0.7924. I'm saying.
All right, 24. Okay. And then what I'm going to do, I'm going to subtract 1. Don't clear your calculator yet. I'm going to subtract 1 from that power, from that number. Subtract 1 from that and tell me what to get, please. So minus 1 from that and tell me what to get.
0.207.
No, man. If you subtract 1 from that, you're supposed to get a negative number.
Oh yeah, negative 0.20.
0.207. All right, and then divide that by 2 for me and tell me what to get.
Negative 0.10.
0.10.
Negative 0.103.
Let me just say the answer up here.
Negative 0.10, sir.
0.104. You have to round off.
4, yeah.
Yeah, 4.
Yeah, 0.104. You see, it's not hard, you know. All you have to do is come to class, participate, and you will catch the something. That's all you have to do, you know. Not a hard this, you know. All right, look at that. Let me reduce this a little.
Sir, don't move the screen, no, sir.
No, wait a sec. Leave me alone, no, Ali. You know, see me try and do something so you can't say everything one time. All right, look at that. Take about 2 minutes and look at that one. Oh, Lord, help me. I'll give you 2 minutes to look at that and then I'll come back to you.
I have a question.
Go ahead with the question, please.
So even though it's a 3 significant figures, the 0 before the decimal point is not counted
Makes
as
it
a significant figure?
Right, makes it significant. Yes, you're correct. So what I should put for that one is 4 significant figures. So the no, hold on. What was the answer? What was the answer again for that one? Tell me the answer again that I have written down.
Negative 0.104.
Right. So the 0 in front, the 0 in front of the decimal point is insignificant. So the first significant figure is going to be 1, and then the 0 between the 1 and the 4 is significant. So the answer is correct.
Sir?
Follow me?
Yes, sir.
All right, cool. Yeah, somebody's saying sir.
I mean.
Oh, okay, cool. Easy.
Sir, You say you're going to send us these notes after the class, right?
As per usual, Andrew.
Okay. Oh, next thing, before I forget, sir. Honestly, I'm not in the best of health right now. I'm not seeing. I just went on to the Edicosoft, and I'm not seeing Precal from
Edicosoft or Arion. Oh, you're not seeing
Arion.
Arion?
I'm not seeing. Yeah.
All right. So what you need to do is to go to the weekend. That's the problem Elizabeth was having too. What you need to go to is weekend. So go to weekend, and you should pick up Precalculus there.
How do I do that, sir?
Sorry to cut you there, Andrew. When you go on Edicosoft and not seeing the assessments also, you know.
No man, go back and look for me, please. Go back and look for me, please.
To Andrew. Yeah.
Yes, sir. How am I going on the weekend?
Go back to Arion to select your courses.
Oh no, I did, you know, sir. I did select Precal and Arion and registered and everything.
Oh, but you're not seeing yourself on
Edicosoft. And I'm not, maybe something is wrong with that for real, because I'm not getting the emails either from.
Don't worry about it. You're not the only one not getting the emails. We spoke about that. That's where we started in the class this morning.
Okay.
And I'm going to be touching base with somebody else to see if there is an issue. Because once you select the course, you should have gotten an email. So that I can't give an answer for, and I'm not going to speak to something that I don't know what is the issue. So let me speak to them about that, and then I can speak more definitively. All right, go and work on those for me, and then go and work on those for me. What I asked you to do a while ago.
Just look at this. You said just look at the.
All right, yeah. Just take another 2 minutes and look at that for me. I'll soon come. All right. So now, that's what we would have gotten for that answer in number 5. And then you make a choice, 6 or 7. Number 6 or number 7, which one you want me to do?
Sure, 6.
Number
6.
6
Number 6. All right. All right, so 12 you say number 6. So let me do number 6. Copy. I will do number 6. Your wish is my command. Paste. All right, so if you look at that one, you recognize that I have to do something first. There is no way I can just go ahead and do that one without looking at trying to evaluate this piece right here. So when I'm multiplying and the bases are the same, what do I do with my powers?
Add them.
Very good. Very good. So I'm going to be adding my powers. So look and tell me if you agree with that. When I'm multiplying and the bases are the same, I'm adding my powers. When I'm multiplying and the bases are the same, I'm adding my powers. When I'm multiplying and the bases are the same, I'm adding my powers. So when I add the powers, I'm going to get x plus x minus 1. And x plus x minus 1 is going to give me what? X plus x minus 1 gives me what? 2x minus 1. Very good. And then I'm going to go through the whole business again. 2x minus 1 log 5 is equals to log 10. It's not changing. It's the same thing over and over we're doing. And then I'm going to divide both sides by log 5. I'm going to divide both sides by log 5 to find my unknown x. I'm going to end up with 2x minus 1 log 5 divided by log 5 is equals to 10 divided by log 5. Log 10 rather, divided by log 5. And then I'm going to have log 10 over 5. Log 5. Log 10 divided by log 5. And then I'm going to end up with now, what is log 10 divided by log 5 equals to? Hello, somebody? Log 10 divided by log 5.
1.43.
1.43. All right. And when I subtract 1 from that, what do I get? When I add 1 to it, sorry, I'm adding 1 to it. What do I get?
Just a answer.
Oh, 2.43.
2.43, yeah.
When I divide that by 2, what do I get now? Hmm? 2.43 divided by 2 is equal to what?
1.21.
5. Yeah.
So I'm going to get my answer to be approximately equals to 1.21. Let me just check up here. Well, actually, I get 1.22. Look and see if we can round off.
Yes, sir. 1.22.
Right. So I get 1.22 for my answer. And that's what it is. So what I don't want you to do is to get nervous, to be worried that the question up here so looks differently from what it is that we're doing. Don't worry about it. You know the laws of indices. You know what Sir taught you. Just go ahead and just work with it. So if it means that you have to go and perform the law of indices, so remember, You can't see the indices and the logarithms come in play together. So you can't just say I go study one and don't study the other. All right. So you have to appreciate both. All right. So with that said, where am I now? All right, let me just look at. All right, I'm not going to do any more. I'm not going to do any more. No. Let me not say
Sorry,
that.
can I just go back on that question, please? Let me get something.
What you want to get?
Yeah, I got it. Sorry.
All right, so actually I wasn't going to go into any more. I will give you the rest for homework. I'll give you the rest for homework. Number 7 is similar to number 6. I want to do question number 9 because 9 and 10 and 11 all look alike. So let me do question number 9, and that's the last one I'm going to do, and then move into something else. Can we agree on that, please?
Yes, sir.
Yes,
all right,
sir.
so all right, so you're going to do the rest of the questions. Remember, I'm going to come back to you with the rest of the questions, come next class, all being well. Remember, students, we have just one, we meet just once per week. So when I give you the work, it must be done. Must be done because it's just once per week that we meet. All right, so we have to get the work done up. All right, now, so this is what is going to happen. This is what is going to happen. For this question, oh Lord, sir, you have 2 sides as an index and the 2 indices, the 2 bases rather, are different. Oh Lord, sir, you never taught us a law to say that if the bases are different and the powers are different, what do we do? What do you think we're going to have to do? Which method?
Sir,
Logarithms, very good. You guys are learning. That's why you need to speak to me in class, because when you speak, I can see you are learning. Very good. So in a case such as this, I have to use logarithms. So look at what's going to have to happen now. I will now have to say x log 3. I'll have to say x log 3 is going to be equals to x minus 1 log 5. And we're going to work the question together, and you're going to tell me whether or not you agree with me. We're going to work the question together, and you're going to tell me whether or not you agree with me. Look at what I just typed a while ago and tell me if you agree.
Yes, sir.
All right, good. So that's what we have there. And then now, what we need, oh Lord, look at this. Remember, we want to keep all the logs on one side, and we want to keep all the x's on the other side. That's how we're going to be able to isolate, and that's how we're going to be able to solve. All right, so look at what we're going to do. I'm going to divide both sides by log 3 because I want the log 3 and the log 5 to be under each other. So, so I'm going to divide both sides by log 3. And I want you to watch closely to this trick. There's a trick right here, and I want you to see it. It's magical. Now, let me just post that first so that you can see what is happening. So what I have done is to divide both sides by log 3. Now, when I divide both sides by log 3, I'm just going to have x on this side. But I'm still going to have an x minus 1 on this side that I don't want. Can you agree with me?
Yes, sir.
Yeah.
All right. So what I'm going to be doing now is to divide both sides also by x minus 1. I have to divide both sides by x minus 1 also, because I don't want that to be there. So look at what it looks like now. So I'm not only dividing both sides by x minus 3, but I'm dividing both sides by x minus 1 times log 3. I'm dividing both sides by x minus 1 log 3. So look at what happens. Look at what happens in a case such as this. Then I'm able to cancel out my log 3. I'm now able to cancel out my log 3. I'm able to cancel out, I'm able to cancel out my log 3. But in the same breath, I'm also able to cancel out from the other side my x minus 1. So in this case, I'm going to have two cases that I'm canceling out simultaneously. All right? Simultaneously. And when I cancel out those, look at what I have on the screen. When I cancel out those, all I'm going to be left with on the left-hand side is x over x minus 1. And on the right-hand side, I'm going to have log 5 divided by log 3. Look at it and tell me if you agree. That's all I'm going to have on that side. Log 5 divided by log 3. Do you agree?
Yes, sir.
What is log 5 divided by
Yes,
log
sir.
3? Very nice. What is log 5 divided by log 3?
1.46.
1.46. Give me 3 decimal places. 1.46 who?
4.
5.
Is it 4 or 5?
5. 1.465.
1.465 is correct. 1.465 is correct. X minus 1. All right. Now watch me. 1.465 x minus 1. I am going to, when I have two fractions separated by an equal sign, what do I do? When I have two fractions separated by an equal sign, what do I do? I cross multiply. I'm going to cross multiply. I'm going to cross
Sir,
multiply.
I was going to say that I'm scared.
No, don't be scared.
I was going to say that, but I was scared.
No, don't be afraid. If you're wrong, we'll just rush you. But don't be afraid.
See, sir, what kind of, sir, that's why I don't want to know, sir, because I don't want to rush you.
No, because you give me too much talk, that's why I rush you. You know, the others won't say that, but me, you give me too much talking. From last week, you give me talking on Ali Bali, but me not say nothing to you, and me and you have a little conversation off the air.
So, I don't talk in class? Oh, my God.
And that's the problem. Mighty God. All right, come, let's go. So when I have two fractions separated by an equal sign, I'm going to cross multiply. Let me just put this over here. And I'm going to put it, that one there, in blue to show you what is happening. All right, so I have two fractions separated by an equal sign. I cross multiply every single time, barring none of the times. So x times 1 is going to be x. X times 1 is going to be x. And 1.465 times x is 1.465x. And 1.465 times minus 1 is minus 1.465. So look at the cross multiplication. For x times 1 is x. 1.465 times this x is 1.465x. And 1.465 times negative 1 is negative 1.465. Now, I want all the x's to be on one side and everything else to be on the other side. So I'm going to subtract. I'm going to subtract x. Well, I'm going to subtract 1.465 x from both sides. So what I'm going to get is x minus 1.465, x is equal to negative 1.465. Let me just cut this right here. So log x minus 1 times log 3. X minus 1 log 3. You see, I do all of this thing for you know, guys. So, because I don't want, when you're revising, that you're not seeing what I'm doing. So that's why I get very touchy feel when I'm in a class and I talk to Uno. And Uno not respond to me because I'm trying to make this thing so much friendly for you that when you're going through, you can see what go on. All right, divide both sides by x minus 1 log 3. Okay, good. So now 1x minus 1.465 looks like it went to leave negative 0.465, don't it? Hello. 1x minus 1.465 x is going to leave negative 0.465x. Talk to me.
Yes, sir.
Good. And then I'm going to divide both sides by negative 0.645. No, I'm going to divide both sides by negative 0.465. What do you know happens when you divide two negative numbers?
Positive fraction.
Very
We
good.
get positive.
You get a positive number. Excellent. So this is what happens. I'm going to divide both sides by negative 0.1465. And then x now is going to be a positive answer. Tell me what's the value of x, please? 1.465 divided by negative 0.465. What is the answer? Don't tell me 1.
A negative 1.93. I'm a phone man. Maybe wrong.
That's fine. Hello, somebody. What's your answer?
I got a 3.15.
Yeah.
Andrew, no, not Andrew. Tajay.
Yes, sir.
Why did you have that answer and sat down on the answer and didn't say it before?
Oh no, sir. I just worked it out a while ago.
Oh, okay. It sounded as if you had the answer, but you say no, say it. All right, very good, Papa. All right, very nice. So I'm hearing, let me just check to see if I had gotten 3.15 when I had done the question before. Yes, x is equal to 3.15 here. Very good. So it is excellent, guys. And again, I'm gonna overkill it because I want the point to come across. You see, when I'm talking in a class, guys, I'm gonna verbalizing something so I can get into the headspace. This is where learning begins. But if you hold the information and I don't know where to go with you, you're gonna complain that me can't learn online because me can't. No, talk to me, man. And we're gonna show the world how online teaching and learning takes place. In this region of the globe, online teaching and learning don't come off. But in other regions of the globe, online teaching and learning pandemic don't affect them because them always use online every single time. There are some people who have never been into a classroom. Them school, we call it homeschooling from kindergarten, homeschooling into middle school, homeschooling to high school, them homeschooling to college, and them go online university. And them get them big jobs still, you know. All bigger job than me and you. Real talk. So let us just do what we must do so that it lightens the work on your path and makes the teacher feels a little bit agitated, less agitated. Come on, we can do this, man. You have been doing pretty well. You are getting the stuff. What I like about Andrew, Tajay, and others is that you are now able to use the calculators to evaluate the stuff correctly. Very good. All right. So with this said, you know how to work the one where you have two of the the things them together. No. As a good little teacher, number 9 looks very much like number 11. Number 10 looks like a combination of something. This is the last question I'm going to be doing before I move into something else. So look at what is going to happen. I am going to give you 6 minutes to work this. G's on P, sir. Oh, you stay so? This is what Alibal is saying. Sir, you never given none with no X squared before, sir.
As if
Yes.
that me nah read some, yes, I can look
Well,
at the question.
so could you know? We are gonna hurt me or you? What you know? Do me a favor, please. My rest of students, work this question for me, please. I give it 6 minutes. All right, so start for me, please. Cool. And Alibali, you're the first one I'm going to call on incidentally. Thank you. Honesty. Hello, somebody?
So it's going good.
Going good? All right, cool. Continue working. I'm right here. Let me know when you finish so we can work on that. So I can introduce something for you to you. And that will take us up to the end of the class. All right, come on, guys. Come on. Let me hear you. Let me hear you. Let me hear you. Mm-hmm. Excuse me.
Mr. Sean,
Yes, please.
you're speaking while you're writing?
No. I'm giving you enough time to do the work, so I'm just doing
Okay.
it in the time.
Okay.
Come on, I want you to do it, and then so I'm waiting
Okay.
for somebody to say that they're finished.
Okay, sir.
Mm-hmm. Mm-hmm. All right, so I'm finished. I'm gonna go now. So we're given the question: 5 raised to the x squared is equal to 25 to the x times 125. So when I look at this equation, I'm seeing where the 5s and the 5s can come out here again, and there's another 5 that can come out here. So I can write everything, the left-hand side and the right-hand side, into a base, a common base. So the mere fact that I know I can write it into a common base, I don't have to use logarithms. I can go ahead and use indices. All right. Now, so I'm going to do conversion. 25 is the same thing as 5 squares. So it's 5 squares raised to the x, and 125 is the same thing as 5 cubes. So now, when I'm multiplying and the bases are the same, 5 here and 5 here, no, lie. Let me do this part first. When I have a base raised to a power, which in turn is raised to another power, I'm going to be multiplying both powers. So this 2 times this x gives me 2x. So I'm going to have 5 to the 2x times 5 to the third right here. And then, of course, it's 5 raised to the x squared is still here. Then the bases are the same, so it's 2x. Since the bases are the same, I can add my powers. So it's going to become 2x plus 3. And that's why I group them like that and put 5 to the 2x plus 3. Now, since the bases are the same, we can equate the powers. See here? The bases are the same, 5 and 5. I'm equating my powers. So I'm going to have x squared is equal to 2x plus 3. Then I'm going to rearrange to give me x squared minus 2x minus 3 equals 0. I no need to factorize. I no need to factorize. And factorizing, I'm multiplying the coefficient of x squared by the constant. This one out here times -3 is -3. I need two numbers. When added together will give me -2, but when multiplied will give me a -3. So those factors are going to be -3 and 1. -3 times 1 is -3. And when I add -3 to +1, I'm going to get this -2. So I have found my factors. And then I'm going to be grouping to give me the first two in one bracket, like so, and the second two in a bracket, like so. Always leaving the middle sign out every single time. Remember, we always leave our middle sign out every single time. And when we leave the middle sign out, then we say to ourselves, what is common here that is common there? X. What is left? When I take an x from x squared, I'm going to have x left. When I take an x from -3x, I'm going to have 3. And then I say, what is common here that is common there? It's going to be 1. What is left? X minus 3. Then I ask myself the question, what is common here that is common here? And you say x minus 3. And what is left will be x plus 1. And of course, that is equal to 0. So either x plus 1 equals 0 or x minus 3 equals 0 to make this question true. So if x plus 1 is equal to 0, it implies that x is going to be equal to -1. And if x minus 3 equals 0, it implies that x is equal to +3. So in this particular case, I have two possible values of x. In this particular case, I have two possible values of x, -1 and +3. Let me check my answer up top. -1 and +3, correct. Look at that for me, please. We'll spend about another half an hour, 15 minutes there about to, where am I? Here, to finish off the question. I'm thirsty, Jesus. Let me just leave this up. I'm gonna get me some water. I'll come back to you. Look through this for me, please, guys. All right, so you should be finished with this by now. Finish looking over that is. Are there any questions before I move on? Can you just look at that summary for me, please, so I can move into the final piece of what it is that I have for you for this topic. Look at the following summary. So we would have seen that log to the base a of 1 is equal to 0. We saw that last week. And that log to the base a of a is equals to 1. Meaning log to the base 10 of 10 is 1. Log to the base 20 of 20 is 1. Log to the base 2 of 2 is 1. And log to the base a of 1 over a is negative 1. So log to the base 2 of 1 over 2 is negative 1. Right? So these three special cases are cases that we need to bear in mind. All right? Now, why did I call that example 2? Calling that example 1. It's a new area. So look at what is happening here. Let me bigify it because I want you to see what is happening. So this one has a lot of write-up because I'm explaining. And when I finish the explanation here, it looks long, but it's not long because I have done a detailed explanation. So we are given a question, 2 to the 2x plus 3 times 2 to the x minus 4 equals 0. 2 to the 2x plus 3 times 2 raised to the x power minus 4 equals 0. So we need to solve. So we need to solve. So we need to solve. So we need to solve this. And how can we solve? Because we have an equation. We're given an equation, so we can solve. Watch me. I will immediately recognize that 2 to the 2x plus 3 to the 2x cannot be combined to give a single expression. Why, sir? And I'm asking you the question, why? Why can't I combine it to give a single expression?
Sir, because the bases are different?
No, because I am not multiplying or dividing. Thanks for your response, but look at this. Remember, the law says the bases are actually the same, 2 and 2. This one is different. But this positive sign, there is no law that we gave that has anything to do with any positive sign. It says when you're adding, when you're multiplying, and the bases are the same, you add your powers. When you're dividing, and the bases are the same, you divide the numerator power minus the denominator power. All right? Now, there is no law we have that we can use to combine these two. So they cannot be combined to give a single expression. Therefore, we need to make a substitution. We need to make a substitution in order to solve these questions. So what I'm going to do is to use the lower of the two. Now, please agree with me that I have 2 to the 2x and I have 2 to the x. And agree with me that 2 to the x is the smaller of the two. Can you agree that 2 to the 2x is a bigger value when evaluated compared to 2 to the x?
Yes, sir.
Sir.
Taj, you were saying something. I faintly hear a yes. Are you agreeing, Taj, or you're disagreeing? Or you're not there yet?
Oh, agreeing, sir.
So I'm going to have 2 to the 2x being the bigger of the two. So what I'm going to do as a result, and this will result in a quadratic equation in y. It's going to result in a quadratic equation in y. The simple rule is to look for the small of the two indices and to make it y. Look for the small of the two indices or terms and make it y. Or really the indices, 2x, x, and make it y. So therefore, I'm going to let y be equals to 2 to the x. I'm letting y be equals to 2 to the x. So when we square y equals 2 to the x, we will get, see here, the square y equals 2 to x. When we square this and we square this, we don't get 4x squared. What we get is y squared and the rule that says 2 to the x squares a base raised to a power, which in turn is raised to another power. You multiply both powers. So I will have to multiply this x by this 2 to give me 2 to the 2x to the law here. That's the law. So because I'm introducing a new topic, I'm going through the whole gamut of it just to show you exactly what is happening. So come on now. So I'm going to, this is a law that we're using. That's the law we're using. And having used that law, we're going to end up with y squared is equal to 2 to the 2x right here. Y squared is equal to 2 to the 2x. Right? So therefore, we now have the substitution for 2 to the 2x and 2 to the x. So I want you to
So
also...
where did the y come from though? Why y?
I am letting y to be equal to the function. Y?
Okay, okay.
It could be u, it could be p, it could be anything there is. I am just letting y be equal to 2 to the x right here.
I understand now, sir.
Right,
I thought there was a reason why I used the y.
Just making a substitution, honey bunches. Thanks for your question. All right, look. So remember, so I'm recalling the question, the given question. The given question is 2 to the 2x plus 3 times 2 to the x. See it here, so? I'm just recalling the question so you can see it. Now I'm going to make a substitution. So now substituting. Now substituting. So this 2 to the 2x, remember we said 2 to the 2x is y squared, so we're going to call it y squared. This 3 is this 3, and the 2 to the x, we'll call it y. So we're going to call it, put y here, the minus 4 comes back. So now I have a quadratic equation. Now I have my quadratic equation. I'm factorizing. I need two numbers. When multiplied together, will give me a -4, but when added will give me a +3. Why, sir? Because I'm multiplying the coefficient of y squared, this one, by the constant. 1 times -4 is -4. And I need two numbers. When multiplied together will give me -4, but when added will give me a +3, this middle term here. So the factors will be +4 and a -1. And I multiply +4 to -1, I will get a -4. And when I add +4 to -1, I'll get +3. So I have found my factors. So look at what I'm doing. This 3, I'm breaking up, of course, into +4 and a -1. And that's why I have it like that. positive 4 and negative 1. And then, just like I did in the question before, grouping to give them 2 first something here in one bracket, them 2 last something here in another bracket. Hold on, sir. Not quite. Because this sign here was negative, sir, and it becomes positive. Remember I told you this trick from long time? That once you have the middle sign is negative, you have to flip this one here. Once the middle sign is negative, the one here so have to flip. Sir, why? Watch me. This negative multiplied by this positive 1y will give me a negative 1y here. This negative 1 that is outside here so multiplied by this positive 4 will give me a negative 4. Besides, whatsoever sign that is here has to be the same sign that is here, or else I'm going to be unable to factorize by grouping. So it must be the same sign. Then I ask myself the question, what is common here that is common there? It's going to be y. When I take out a y from y squared, I'm going to have y left. I'm going to have y left. And when I take out, what do I factor from 1y plus 4? So you're not seeing anything? Yeah, man, 1 is a factor of everything. So what I can take out is a negative 1. Then I'll have my y plus 4. Then I ask the question, what is common here that is common there? And then your answer is going to be y plus 4. I take out the y plus 4, then I'm going to be left with y minus 1 right here. So, and it is the same thing that we did before. Either y plus 4, the piece here, equals 0. Look at what we do. We don't carry nothing over no equal sign. Like what I'm telling in a local school. We are finding the additive inverse of this positive 4y, this positive 4, I'm sorry, to be negative 4. So I'm adding negative 4 to both sides. So this is why I add in red. I'm going to add negative 4 to both sides. These two numbers cancel out. So I have y equals 0 minus 4, which is really y equals negative 4. And I do the same thing here on this side. So y is going to be equals to positive 1 right here. So either y equals negative 4 or y equals positive 1. Here may recall. Here may recall. I'm recalling that we are the ones that introduced y into the question. That's the question Donnie just asked a while ago. So where did y come from? Or we put it in there? The question never given up. We don't know why. So since we put it in there, I have to take it back out now. We put it in there. Then, sir, if you put another variable in there, you'd have to take it back out too. Yeah. Because the question was in x alone. Question was only in x. See it here? 2 to the 2x plus 3 times 2 to the x minus 4 equals 0. No other variable inside of this, but just x. So because we introduced a variable for the sake of substitution, we need to take it out. So therefore, we now need to remove it. And how do we remove it? We now need to make the substitution. So if we're saying that y is equal to negative 4 and 2, let me just do this recall. Let me put a recall here. Recall. Y is equal to 2 to the x. Where do I have that? Recall y is equal to 2 to the x. Copy. Recall y is equal to 2 to the x. So we now need to make a substitution. We need to make the substitution. So wherever we see y, we're going to put negative 4. So we're saying 2 to the x is equal to negative 4. And we're going to have, the other one was 1, 2 to the x is equal to 1. All right? Let me just flip this around for ease of seeing what is happening. I know some students will have a difficulty seeing. Same difference, doesn't matter. So y is equals to 2 to the x, y is equals to negative 4. See to yourself, so I put negative 4 equals 2 to the x. Y is equals to positive 1, see to your 1 is equals to 2 to the x. There are no real values for x that satisfy 2 to the x equals negative 4. I cannot take the logarithm of a negative number. Doesn't work. Doesn't work. So what does this mean? You cannot take the logarithm of a negative number. Never, ever, ever can you take the logarithm of a negative number. It doesn't work. So therefore, we have no solution for that value of x. So there's no solution that will satisfy this value of x. Now we need to investigate the other one. And this is the investigation. 2 to the x is equals to 1. So we're going now, just like we did just now. We can't write the right-hand side into a base 2, so we have to use which method?
Logarithm.
So we're taking the log of both sides. So it will be x log 2 equals log 1. See it right here, so? Same thing we have been doing all along.
So, you say a while ago, you say about the right side. What you say about that side?
This right side here, I can't write it in a base with a 2.
You say you can write it to an index.
See it
The
again?
same base.
Right.
So, that's what you mean by right side and left side. I understand this, but when you say left side and right side, I wonder what you're talking about. But
Yeah,
I understand now.
Yeah, man, remember we did talk one story, or maybe other story they go up there again. See that? We said the story, you know. Remember
I
when?
remember that I wasn't here, so I never get that part.
Oh, yes.
Yes, sir.
You walk the road. Jeez, you see for what boat, you know? All right, never mind. You see, when you get the document, honey, this is what we talk about. I did a summary right here. When both sides of the equation can be written in the same base, then we can use either indices or logarithms to solve the equation. If on the other hand, only one side can be written to a base, you must use logarithms to evaluate the question. So this is it. Come on, this is it. It's only one side that can be written. I thought you were going to ask me another question, and that's why I paused. Do I have alternatively? Yes. But for now, we're going to say that this side can't be written to a base 2. I mean, with a base 2. So we're using logarithms. So we're going to have x log 2 is equal to log 1. And then I want to find the value of x. I'm dividing both sides by log 2. See here? And the log 2's cancel out here. So I'm going to have x is equals to log 1 over log 2. And that is going to be my answer to be equal to 0. My answer is going to be equal to 0. Isn't this the same thing? Hold on, isn't this the same thing that I have here? X log 2. All right, so I copied it, but I didn't actually express myself with the alternative method, because this looks exactly 2 to the x equals 1, x log 2 over log 2 is equal to log 1 over log 2, so x is equal to log 1. All right, so alternatively, I can ask myself, in this particular case, I can say, what number can I have as a base 2 that I can raise 2 to give me 1? What number can I raise 2 to give me 1? 2 to what give me 1? Can somebody answer me, please?
So 2 to what give you 1? I didn't hear the last part.
Yeah, 2 raised to what number will give me a value of 1?
0, sir.
Very good. Yeah, man. So tell me then, no? Very nice. 0. So now that I have 0 here, I can say, since the bases are the same, we can equate the powers. So since the bases are the same, we can equate the powers. So x is going to be equal to 0. So this is another quick way of looking at it. All right. Sir, that means we can do the question like this all the time. Sometimes, you know, we get 2x is equals to 1. Just those that are mathematically mature can convert this 1 to 2 to the 0, and that will be perfectly correct. Now you have both bases to be the same. We can go ahead and equate our powers. So we get our x equals 0. All right. Now, that is just the introduction. I'm happy that I was able to do the introduction because see, I have some 14 questions there for you. Don't worry about it. I was really very tired. So I did 1, 2, 3. I did question 1, question 2, then question 6, 7, and I didn't do any more. But you have the answers for, all of them except 8, 9, 10, 11. Right? And that's the end of the document. That's the end of the document. So my homework is to see if I can do the other questions for you for class next week. So this is the end of this document. So clear the plan. I'm not going to be coming to class next week, all being well, to sit and work these questions here for you. What I will do is to come to class to find out the difficulties you're having with the questions. And the ones that you have difficulties with are the ones that I'm going to be working out, right? So that's it for today. It worked out to be a very good class to the latter parts of it. The earlier parts, I was a little agitated because you guys weren't doing what was expected of you. I really hope that come next week, you guys will come fully prepared for sir. Put on the right attitude for class next week, guys. And we should be good to go. Taj, are you okay? Tajay?
Oh, yes, sir.
Are you following what is happening?
Yes, sir.
Are you having any difficulties at all?
No, sir.
All right, let me tell you the reason I'm asking. Because you were the last addition to the class. And I did ask you to go through the recordings, the previous ones. If you're having any difficulty in whatever shape or form, fret not, reach out to me. My days are filled with meetings. Elizabeth can tell you, my days are filled with meetings, but reach out to me. I will respond to you, all right? And the rest of you too. You're having a difficulty, I would prefer if you're having a difficulty, you get my attention in the WhatsApp group first, than you pulling me out of the WhatsApp group and having a conversation. Say, for example, I may not have Andrew's number stored to my phone, but Andrew's in the WhatsApp group, and Andrew called himself Mr. King.
Sir, excuse me.
I
have to leave now, okay?
Okay, no problem.
Thank you again.
Bless you. And Andrew called himself Mr. King. Now, when I look in the WhatsApp group to find Andrew's number, I can't find it because I don't know that he's Mr. King. When Andrew sends me a message, I don't know who it is that I'm necessarily talking to. And sometimes I can't, go and try and find out who it is because I'm teaching so many groups with so many students. One group has 26 students, the other group has 20 plus, and your group have 13. So get my attention in the WhatsApp group first. And then we say, all right, let us pull out. And then we have a private conversation thereafter. But drop your concerns or your questions in the WhatsApp group now. Trust me, there are students in the class here that are understanding and they'll be quick to answer you. But with that said, thank you for coming out. Have a good one. Please to start working. I'm going to send this document off immediately so that you can start working on it for me. All right?
Okay, sir.
Best up. Take care.
All right, sir. Bye-bye.
You too.
Bye, sir.
Bye-bye.
Bye, sir.
Yeah, man. Easy.